Let's look at the 14th proposition of book 2 of elements. The proposition says that we have to construct a square whose area is equal to the area of a given rectilinear figure. Here it is A, B, C, D. This figure area has to be converted into a square whose area is the same. So the first thing that we do is we convert this figure into a rectangle or rectangular parallelogram. We know how to do this. Since it is supposed to be a rectangular parallelogram, the angle is fixed at 90 degrees. Now this is based on proposition 45 of book 1. Now let's start the construction for constructing the square equal to this rectangle. What we'll do is we will convert this T1 U1 as a straight line straight on to D1 T1. So we draw this line, we draw a circle whose radius is equal to T1 U1 and we mark the point of intersection and we connect these two points. So now we have T1 A2 equal to T1 U1. The next step is to mark the midpoint of D1 A2. Again, we know how to do that. So we have got B2 as the midpoint of D1 A2. Let's remove all these elements. The next part of the construction is we draw a circle. Semicircle is enough with center at B2 and D1 A2 as the diameter. And we extend T1 U1 so that it intersects this semicircle. And we mark the point of intersection. And we join B2 C2. Now we have to build the square on T1 C2. Again, we know how to build the square. Yes. So we can hide these circles now. This square has the same area as the square area of this rectangle, which is in turn equal to the area of this figure. That means the area of this figure is equal to the area of this square. Now let's actually prove that it is actually true. You notice D1 A2 is a straight line, B2 is the midpoint, and T1 is a point on the line. This should remind you of proposition 5 of book 2 or 2.5. Proposition tells us that D1 T1 times T1 A2 plus B2 T1 square is equal to B2 A2 square. But B2 C2 and B2 A2, they are both same because they are both radius of the same circle. So which means our expression or equality will become D1 T1 times T1 B2 square is equal to B2 C2 square because B2 A2 and B2 C2 are equal. But what is the significance of this B2 C2? This is the hypotenuse of the triangle B2 T1 and C2. So B2 C2 square is equal to B2 T1 square plus T1 C2 square. So our equality will become D1 T1 times T1 A2 plus B2 T1 square is equal to B2 T1 square plus T1 C2 square. You might have noticed that B2 T1 square is appearing on both the left and right hand side of the equality. So we can cancel them. So when we cancel them out, what are we left with? We are left with d1 t1 times t1 a2 equal to t1 c2 square. But t1 a2 is equal to t1 u1. So we can substitute it and say d1 t1 times t1 u1 is equal to t1 c2 square. d1 t1 times t1 u1 is nothing but this rectangle, which is equal to t1 c2 square, which is nothing but the square on t1 c2. So these two are equal, and based on the proposition 1.45, the area of this rectangle is equal to this. So that means the area of the square is equal to the area of the given figure. So that is book 2, proposition 14. Again, when I'm describing the proof, it can become a little bit confusing. Please feel free to download the PDF book which I have provided as a link in the video description and refer to it, where I give the detailed constructions and proofs of all the propositions. That's it for now.